Thanks for this great presentation. I think that's the first time I've had such a presentation. Like if you've seen Game of Thrones, like Daenerys, she has such a long title. Yeah. So thanks. All right, it's really great to be here. I hope you all had a great time so far at the conference. I've really had a great time myself. I've been here, this is the first time I'm here, and I'm here to talk to you about Azure Table Storage. So how many of you work with table storage today? Okay, just one and two. All right, that's good actually, because then I'll talk to you about this and then show you how you can get started with table storage and why it's good, why it's not so good, and so on. So yeah, so you've already seen the presentation of myself, so I'm not going to repeat that again. But as you can see here, I'm a solution architect at Making Waves. And as you can see from the slides, I love drinking coffee and I love cats. So that's why you see this. OK, so I'm here to talk about Azure Table Storage in 2018. Now, table storage was released back in 2013, so it's been out for quite a long time now. But I'm here to talk to you about table storage, how it is today, how it stands out today. And later on in the presentation, I'll also talk about table storage compared to Azure Cosmos DB, which is the new kid on the block these days when it comes to NoSQL databases. So yeah, if we look at 2018 and we look at the technologies out there, you'll see that there's quite a lot of NoSQL databases that you can use. It's really quite crazy. If you look at the slides, these are some of the NoSQL databases out there. There's even more than that. So it's really crazy. There's a lot of such technologies that can be used. But so we'll look at the motivation behind Azure Table Storage. Yeah. So if you look at all of those technologies, and it's really like this. Each NoSQL database really has its good side and its bad side. So there's always pros and cons. And we're here to talk about table storage. And this is the logo for the Azure Table Storage, just so you know. OK, so let's look at the pros of using Azure Table Storage. So it's really easy to set up. It's cheap. It doesn't require a lot of work to kind of get it up and running in your application. It's really easy to understand. It has a really simple model. It has this entity. You have a partition key and a row key. And it's a NoSQL database, right? And what does that mean? It means that there are relational connections between the entities. It's a blob storage. OK, what about the bad things about Azure Table Storage? So it's not so great when it comes to scalability. It has a lack of some really basic database operations, such as like or contains. There's no such operations that you can use when you query your data. You have to write your own custom operations in order to do that. And you have to do that in the code, of course. I'm going to show you lots of code in the slides. I'm going also to share the slides later on, so you can get the code and see how you can use this in your application. But everything is written in the code when you set up Azure Table Storage. So if we want to use like custom operations, we have to write custom code for that. We use C# for that. Of course, there are also other libraries, wrappers for Azure Table Storage, so that if you're working with mobile, for instance, you can use Android library and iOS library. I'll show you that later on. And also, there's no backup procedure when it comes to Azure Table Storage. You don't get that out of the box. You have to do that yourself. Now, if we compare that with Cosmos DB, for instance, you get a backup procedure. But just so you know, Cosmos DB isn't better necessarily than Azure Table Storage. It's more like another technology that you can use. There are a lot of companies that use, for instance, both of those technologies. They use Azure Table Storage and they use Cosmos DB, both of them. So it really depends on the different scenarios out there. So, OK, so let's just jump into this. Let's look at code. So firstly, how do you set up and use table storage? Now, if you look, first you have to go to the portal, to the Azure portal. So you go to portal.azure.com. And you need a subscription, Microsoft subscription, and an Azure subscription also. So you go to storage accounts, you click on add. You have to have a storage account first. So this is how you do this in the portal. You simply select, click on storage account, select the storage account, click on access keys, and then you can get the connection string. Connection string is really important. That's where we connect to the table storage in the cloud, right? So this is where you get it from. And as you can see in the slide, I have censored out the connection string because you don't want to have connection string as clear text in your code. You should never do that. You can use Key Vault, Azure Key Vault, in order to build up your connection string. This is what you should do. So once you have done that, you go ahead and download the Azure SDK, which is available on the MSDN site. You download it there, and then you'll get several tools here. The important stuff here that we get, we have, for instance, the storage emulator. You need that when you work with table storage locally on your development machine. And also, you should download the Azure Storage Explorer. This is a really nice tool that gives you a very nice UI that shows you how you can connect to table storage and do several things there. As you can see here, I've just marked 4 different things that I'm going to talk to you about. It's blob containers, file shares, queues, and finally tables. These 4 things I'm going to talk to you about. OK, so let's look at code. Of course, I understand that you probably can't read the code, at least in this slide. So don't worry about that. I'm going to share the slides with you, so you'll see the code in better, but in any case, this is how we connect and create a table. We firstly give a name for the table. We use a cloud table object. And here we have just a service class. And then we're injecting the Key Vault fields here to build up the connection string, which we're doing here. And then we're just parsing connection string and creating a table client. So it's simple as that. So this is an entity. This is a typical entity that you save into the table storage. Here we have a customer entity, which inherits from table entity. And for this entity, I have 2 fields. I have a last name and a first name. Partition key is the last name, the row key the first name. It's up to you to decide what is the partition key, what is the row key. Entirely up to you. Here's how to insert an entity into the table. You use the table operation object here, and then you use the insert, and then you create a new entity, and then you execute the operation. Here is how to insert a batch of entities, because you want to do that. If you want to store lots of entities at the same time, you should use the table batch operation, because that's much more efficient than inserting singular entities. So use this batch operation object, and here you insert 100 batches of entities at the same time. This is why I'm showing you here this loop here that has 100 entities, because the maximum is 100 when you want to insert a batch of entities. OK, here's how to get an entity. We use a table query object. We create a filter, and then we provide either a row key or a partition key. Here I've used the row key, and then I execute the query, get the entity. Here's how to delete an entity. We first retrieve the entity. This is what I'm doing in the first line here. And then once I have done that, I delete the entity by using the delete operation there, as you can see. All right. Now let's talk about blob containers. So what is a blob container? A blob container is really similar to a folder that contains a collection of blobs. And a blob is a file of any given format. It can be a JSON file, PNG file, JPEG file, and so on. Here's how to connect and create a blob container. You first define the container name at the top here, which I've given it customers. And then we use the cloud blob container object. Then we pass in the connection string. We get the reference to the container, and then we create it if it doesn't exist. OK, now blobs, they can be uploaded and downloaded to the cloud, right? To upload a blob. In this case, I'm uploading a JSON blob. First, I get a block blob reference to the blob. And then I'm using a memory stream here, serializing the JSON, writing to it, and then afterwards uploading it from the stream. Here's how to download the blob, really easy. You provide the blob name, you get the reference, and then you define a file to download to. In this case, customer JSON. OK. Here's how to delete a blob. You first get the reference to the blob, and then you delete it if it exists. All right, let's go over to queues. Queues are also possible to use. And are like they give you asynchronous messaging between different application components, and they're really great to use as well in this case. And it's basically a service to store messages that can be accessed from anywhere. And yeah, a single message is up to 64 kilobytes in size, and a queue can contain millions of messages. Now, it's really funny to talk about queues when I'm here to talk to you about table storage, right? But this is possible, at least. Microsoft has lots of such technologies that can be used out there. Queues is one of them when it comes to here. So, OK, here's how to connect and create a queue. You define the queue name. You pass in connection string, same idea. We create the cloud queue client object, and then we get reference to the queue, and then we create it doesn't exist. Here's how to insert a message. You use the cloud queue message. Here I'm providing it content, and I add message to the queue. Now you can also peek at a message in the queue. That's really interesting. Really looking at what is there in the queue without removing a message from the queue. You peek at the message, look at it, removing it from the queue. You can do that using peek message async here. Here's how to update message content. You set the message content, and then you update the message. And in this case, we're given this, as you can see here, this time span here means that for this amount of time, I'm doing a change to the queue, but in this case, I want to, don't do any changes outside the queue for 60 seconds. So for 60 seconds, you're kind of locking the queue, and then you're doing the update, and after 60 seconds, it gets updated, and everyone can see the change. Here's how to delete a message. You basically get the message first, and then you delete it. Okay. This is getting a number of messages from the queue. You can also do that using the approximate message count, as you can see here. OK, the last thing I want to talk about is, the last thing is file shares. So file shares are really easy. They're just about uploading and downloading files to the cloud, basically. It's as simple as that. And they can be mounted on Windows, Linux, and Mac OS. And you also have snapshots of file shares. So you can take a snapshot of a given file share, and if something happens, you can always revert back to the snapshot that you created. Something happens if you delete something by mistake or some error should occur, you can always revert back to the snapshots. Now, to use file shares, you do that in the portal as well. As you can see here, you have to have the storage account. You select it. You click on Overview, click on Files, which you see here, and you'll get to the file share. OK, now I want to talk to you about performance, which is a really, really interesting thing, right? Now, I can't talk about performance without mentioning Troy Hunt. How many of you have heard of Troy Hunt? Some of you have heard of him. He's this security guru, he's the security MVP. He's also Microsoft's regional director. And he worked with table storage and did a performance test when it was released. And it's really interesting. He wrote a really nice article where he used it in his website. And he did some tests that are really interesting that we'll take a look at. Now, what's really interesting is that when I created this talk for you, I read his article, and I found this title here, which looks really similar to the title of this talk. So I was really shocked. I had no idea. It's a really coincidence, but my talk is more pessimistic, of course, than this title. Yeah. So Troy did some tests, as I mentioned to you, and in this case, he created, for instance, 9 different, as you can see here, we have 9 different importers, 9 different processes inserting entities into the table storage. And here, he measured the average speed at 22,500 inserts per second. That's really impressive. That's really, really nice. So when it comes to that, table storage is really fast. And also, he has this API where you can provide your email address, and then you can see if your email has been hacked or compromised on the web. And as you can see here, doing one query of 154 million records returned in 4 milliseconds. Really impressive. So table storage is fast, fast, fast. OK, now, table storage versus Cosmos DB. Cosmos DB, the new kid on the block, how do they work? Right? Now, table storage and Cosmos DB are similar. There are some similarities. Now, table storage, as I mentioned earlier, doesn't have a backup procedure, while Cosmos DB has this. Now, when I mention this, I also want to tell you that you can use Cosmos DB, and there's this facade I've heard about, table storage facade that you can use in the Cosmos DB world, where you can then get features from Cosmos DB in the table storage. So you can do that. But the main difference between those two is that table storage has storage-based pricing, which means that it costs per storage, while Cosmos DB is throughput-based. So this means that it's really better to use table storage when it comes to cost. So table storage aims at high capacity on a single region, while Cosmos DB aims at a global distribution and high throughput. So choosing which one of those two really depends on different scenarios, as I mentioned to you. But yeah. the biggest difference, as I mentioned, is storage-based pricing in table storage versus throughput-based in Cosmos DB. All right. Now, the last thing I want to talk to you about is mobile apps. Now, Azure Table Storage is a good choice for mobile apps. You can definitely use it if you want, but there's something better, something called Azure Easy Tables, which you can use, which I also recommend that you do. It's backed by Azure SQL and geared towards mobile development. But if you still want to use table storage, you can absolutely do that. There are libraries for iOS, which you can use under the Azure organization on GitHub. And also there is a library for the Android phone under the Azure organization. And I'm not going to mention Windows Phone because there isn't really like a library for that, but you use it anyway, so you can test it out. It will probably work. But unfortunately, Windows Phone has really dropped in popularity. So yeah, it's really a shame, really. So, okay. Now we've looked at all this. Now, what about the way forward? What about the future when it comes to table storage? Now, table storage will live on, we hope, of course. We hope that it doesn't get deprecated one day by Microsoft. It could happen, we never know, but it still lives on, and it has lived for the past 5 years, so we're really optimistic about that. So it definitely needs further support and new functionality. The lack of basic database operations is a problem. It's definitely a problem. We need it to be more smart. We need more operations that we can use in our applications. But as I mentioned earlier, the ease of setup and use of table storage is a really definite plus. It's really easy to get up and running. You can get it up and running in like an hour, so it's really easy, and that's really where table storage shines. So that's pretty much it. I hope I have inspired you in some way to use Azure Table Storage in your applications. I hope you have learned something in this presentation. Thank you very much.